Hello, everyone. Welcome to another day of physics. Um, we are going to get started today with our warm up for the day. Um, so in this particular problem here, we have a car traveling at 30 meters per second for 15 seconds, and it ends up being 100 meters north of their house. Where did the car start? You can assume that the car the north direction is positive and the south direction is negative. And you can remember that if you are unsure what formula to use, just remember that displacement is velocity over time. So what I thought we would do today is I have a little poll here for you to fill out. So if you are, whenever you finish solving the warm-up, you can just respond to the poll, and there should be a bunch of different answers in there for you. If you aren't sure how to do it, you can always answer I don't know, because that helps me as well. If none of the answers above fit, you can also type your answer in the Zoom chat. So I have an option for that as well. So there's plenty of options for here. So again, to reiterate the question, if a car travels at 30 meters per second for 15 seconds and it ends up being 100 meters away from 100 meters north of their house, where did the car start? And you can assume that north is positive and south is negative. And remember that displacement is velocity times time. So there should be a few options in here. We have 22 people here so far. So our goal here is to shoot for an 80% response rate. I believe that's around 18 people. If we can shoot for 18 people responding, I'll be very happy. We got 4 so far. Thank you for all of those who responded. Let's see if we can get some more. So once again, the warm-up question of today, a car is traveling at 30 meters per second for 15 seconds, and the car ends up being 100 meters north of the house. Where did the car start? That is what we're trying to find. We'll take another 2 or 3 minutes to try to figure this out. We have 14 people who responded. Thank you for all those who responded. Got 15 people, so we got 15 out of 24. I'm very happy with that so far. Our goal here, let's shoot for 80%. 80% response rate. That's around, what, 19, 20 people? Well, we're shooting for a B today. Shoot for a B, we're at 66%. Ooh, that's pretty good. We're almost there. We got a bunch of different answers here. We got a nice spread of answers. Again, the warm-up problem, if car travels at 30 meters per second for 15 seconds and ends up 100 meters north of the house, where did the car start? You can assume north is positive and south is negative. Remember that displacement is velocity times time. So that's an equation that will help you a lot in terms of figuring this out. We have 16 responses out of 25 people. Our goal here is to shoot for an 80% response rate. I think another 2 minutes or so. We got 17 out of 25, 18 out of 25. I think we just need 2 more people. 2 more people. We got 18 out of 25. Shoot for 2 more people. 2 more people. Ooh, since we have, now we have 27 people, which means we need more responses. We're at 66%. We got 18 responses. We're shooting for 80% today. 80%. We're shooting for 80%. We'll take another minute or so, and then we will move on. We have a 70% response rate. That's pretty good, but we are shooting for a B today. So we can get a few more. We got 60. Oh, we got six. One person just joined. We're at 67%. I'm gonna close the poll in 30 seconds. If you just joining us, answer the one question real quick. Let's get some responses in here. You got 23 seconds.
Can I go grab my root beer?
Yes, go grab your root beer.
Thank you.
Okay. Okay. All right. So let's take a look at our responses here. So we have most people have decided that it's 350 South. We have a very close second response at 550 North. We have a few people who aren't quite sure of how to do it. And last but not least, we have one person who said none of the above. So it could be any of these, but we will see which one it is. Thank you for all those responding. We got a good response rate today. We'll shoot for bigger and more numbers next time. So what I'm going to do here is I'm going to start going over this problem here, and we'll take a look at how to do this. So how do we do this problem? So the first thing we want to do is let's visualize the problem here. And to do this, we're going to want to identify our reference point for this problem. So our reference point for this problem is we are using our home as a reference point. So we're comparing everything to home. So what does it mean to compare everything to home? It means that we're setting this as a reference point. So this is a reference point here. And we're setting this to be x is equal to 0. The reason why we're doing this is because this is our reference point. So we're comparing everything to our position to here. And we ended 100 meters north. So we ended somewhere here, x marks the spot. Now this particular position, our x is equal to 100. We want to figure out where we started. So let's break down a little bit our information a little bit more. So our car is traveling at 30 meters per second for 15 seconds. So in this particular problem, 30 meters per second, it's a positive 30 meters per second. So which means, because it's positive 30, it means that our car is going northwards. So we are going north and we're ending up in here. What's important is that we are not starting from 100. We're starting from somewhere here, and we're going up to here. So we're traveling north, going up to here, and we're ending at 100 meters north of the house. So, and we're traveling at a speed of 30 meters per second. What we're going to want to do here is now we're going to want to now identify where we started off with. So what I'm going to do here is I'm going to identify how, what I'm going to do here is I'm going to show us how to do this in terms of some equations. So the first thing we know is that the displacement, in other words, how far the car went, is our velocity times time. Right, so our car is traveling at some velocity for some time, and then so thus it will cover some displacement in some amount of time. So in this particular problem, our velocity is 30 meters per second. We travel for 15 seconds, which means our displacement 30 times 15 is 450 meters. So in other words, the car traveled 450 meters north in order to end up at x is equal to 100. So in other words, our starting position plus 450, because we're going 450 meters north, is equal to 100. Right, we're ending at 100. We're starting somewhere here. So we started somewhere. This is how much our position changed by. I'm going to get 100. So if we subtract this out, our starting position is x is equal to negative 350. This is negative 300 meters. And because this is negative, this also means 350 meters. So what we can do is we can also express this idea in terms of an equation. This is going to be a little new, but I think you probably have seen this in some shape or form before. Let's say I want to figure out what my position is at any given point in time in this journey. So what I want to know is I want to know what my position is at any given point in time. So the position I have at any given point in time is where I started off from plus how much my position changed. All right, so where my position is at any given point in time is where I started off from plus how much my position changed. So how much does my position change? My position changes by our displacement. Our displacement is our position change. And this is equal to our velocity times time. So instead of saying plus our position change, what I can say is this is just our velocity times time. Okay. And what I can say for our starting position is I'm going to use the variable x sub 0. So this is very confusing for a lot of people, and I totally get it. So this is called a subscript. A subscript is like a little it's a little zero. It's not a big zero, and it's a way to show to tell us more about this particular variable. So this is x sub 0 is not the same thing as x times 0. It's like a label. It's like a label. It's like imagine if you had it's like a little label that tells us something. And then we use we can use x subscript 0, in other words, x little 0 as a way of saying our starting position. So our position at some time is our starting position plus how much our position changed, which is our velocity times time. So this equation right here is something you're going to want to write down, because we're going to be using this a good amount for the rest of as we finish up the velocity unit. So this is something you write down, and this is how this is a good general equation that'll help you solve any problem. And so we can actually use this equation here to solve this problem again. So what I can do is I can say that my position at some time at the very end is 100. My initial position, we don't know this. My velocity times time, my position change is 30 times 15. So if I solve this out, I get that my x naught is just negative 300, just like we did previously. So this general equation is something we're going to use a lot to try to solve more of these word problems. So this is something you write down. We will have a little bit more practice with this later on, but this is a good general equation. So hopefully this makes sense. Some key ideas here that we want to know is we are traveling 30 degrees per second north because this is positive, and we are ending at x equals 100. We're not starting here. Our reference point is home, which is x is equal to 100, and we want to figure out our initial position plus how much the position changes. Yeah. Does that make sense for people? Does anyone have any questions about this?
The M stands for meters, right?
Yeah, M stands for meters, yes. Okay, so what we are going to do for today is we are going to do,
Can you go back for 1 second, please?
Oh, yes.
Sorry.
Go ahead. Yes. Okay.
All right, we're good.
Okay. So what we're going to do today is we are going to review the Codenames velocity assignment we did last semester. So I want to do a quick review of it. Of a couple of questions on there that I think could be helpful to understand. The key is posted on Canvas as well. So I would recommend going a look at the key to double check some of your work. Then we will begin a continuation of it. I call it Koenig's velocity part 2. It's basically looking at one specific graph on the assignment, and we're analyzing it to a very high degree, very explicit examination. And the due date for that, I'm setting it to be due before next Thursday, Friday. So we'll have today and next Tuesday to work on it. The assignment is going to be very similar to the Koenig's velocity one, but it's going to be a lot more in depth. And so I will give you, as I'm going through the Koenig's velocity one, I'm going to give you an in-depth examination of how to do the problem. So let's first start off with story. Well, so on the key, let's first start off with story. What's a good one to start off with? Let's first start off with story VII, story 7. And I'm going to just quickly, so on story 7, the table that goes with it is table U and everything. All of this is on the key that I posted on Canvas. I would recommend going through that right now. So the table looks something like this. You have time, position, 0, 1, 2, 3, 4, 5, 0, 30, 60, 0, 60, 20. Okay. So what I'm first going to show you how to do is to figure out our average velocity and average velocity. So our average velocity is, in other words, is our average velocity for the whole trip. So we know that velocity is displacement over time. And so when we want to deal with average velocity, we're going to want to deal with total displacement over our total time. So what does it mean to have a total displacement? Where our total displacement is basically how far did we go from our starting point at the very end. So our total displacement, we started off at 0, we ended up at 120. So our total displacement is 120. It's literally just the difference between the starting and the position. So our total displacement is 120. Our total time is 5 seconds. So our average velocity is 24 meters per second. Now to figure out our average speed, we're doing something similar, but instead of total displacement, we're going to use total distance. So our total distance is different than our total displacement, because in our total displacement, we don't care that we went backwards. We only care where we started and where we ended. For our total distance, we care about how far we went in the whole time. So between 0 and 30, we traveled 30 meters. Between 30 and 60, we traveled another 30. So we traveled 60 here. We traveled another 60 backwards. So now we traveled a total of 120, not 0, 120. 60 here, 60 back. We traveled another 60, so now we're at 180, and another 60, so we're now at 240. So our total distance is actually 240 meters. Our total time is the same at 5 seconds, and so our average speed is 48 meters per second. So this is very important here. Recognize the difference between total average speed and average velocity, and we're looking at the difference between distance and displacement. Very important. So what I'm going to do now is I'm just going to graph out the position versus time graph for position versus time graph. This. So in general, right? We want time on the x-axis. We want our position on the y-axis. This is because time is always independent, whereas our position depends on how much time we're at. So this in terms of increments of 30, so 30, 60. I'm just going to draw this. Okay, so initially we're at 0, 0, then we're at 130, then we're at 260, then we go back to 0, we go up 60. This is what our position versus time graph looks like. And if you look at the graph on the key, if you would actually plot it out, right, it matches it perfectly. The shape of it matches it perfectly. The line's a little dense. So from our position versus time graph, we can actually identify our velocity for specific intervals. So one thing you should consider is that our velocity is the slope of a position versus time graph. So if I want to figure out my velocity at any given point here, I just want to figure out my slope. And because for any given interval where the slope is the same, that means our velocity is the same. So if I want to figure out my velocity is what my velocity is at time is equal to 1, because this is one line here, it's the same as any velocity between 0 and 2 seconds is going to have the same velocity. So all I can do here is I can just figure out what is my average velocity between 0 and 2 seconds. So if I want to figure out my velocity, that's t is equal to 1 second. What I can do is I can figure out my average velocity between this interval. So I can actually figure out, this is the same thing as my average velocity between 0 and 2. And this is because between 0 and 2, it's one linear line that has the same slope. So between this, everything in this interval will have the same velocity. So to figure out our average velocity between 0 and 2, we're going to do something very similar to what we did previously. What we're going to do is we're going to look at our total displacement. So we started at 0, we ended at 60. So our total displacement is 60. This occurred over 2 seconds. So our velocity at t is equal to 1 is equal to 60 over 2, and this is 30 meters per second. And this means that our velocity at time is equal to, that means our velocity at time is equal to 1.5, time is equal to 0.5, it's all going to be 30. Okay, so what about at our velocity at, I don't know, time is equal to 2.5 seconds? Well, it's going to be something similar. This time our position, we started off at 60 and we ended at 0. So our total displacement was actually negative 60. And this occurred over 1 second. So our velocity here would actually be negative 60 meters. And then last but not least, for between 3 and 5 seconds, let's say I want to figure out my velocity at 4 seconds. What I can do is I can say that my initial displacement position was 0, my final position was 120. So my displacement was 120, and this occurred over 2 seconds. So my average velocity was 60 meters. So this is how you find your velocity at any given point in time. If I want to figure out my speed, so speed is basically our velocity, but the thing you should remember is speed can never be negative. So our speed here is also 30. Our speed here is just positive 60, and our velocity here is speed here is 60 again. So our speed is 30, 60, 60, velocity is 30, negative 60. And to finish this off, one thing we're also going to want to consider is how to draw a velocity versus time graph. this. Velocity versus time graph is just going is we're literally just going to be graphing our velocities between these intervals. So so for the first 2 seconds, our velocity is 30 meters per second. So it's going to look like this. But between 2 and 3 seconds, it's going to be down here. I got a line to make this. And then between 3 and 5 seconds, it's going to be. So to draw a velocity versus time graph, to do this, you need to know the velocity for any given interval, and then you're going to plot it on a graph like this. Your velocity is constant within any interval, which is why your lines are horizontal. But when you're switching intervals, you're going to draw a little dotted line here. It's disconnected. You're going to draw a little horizontal line where this velocity is. And so it should end up looking something like this. And so if you look at the answer key and you look at the graph that goes with it, it does match it perfectly once again. It's a horizontal line, goes down, another horizontal line, goes up, another horizontal line. Okay, so this is a lot of information. I know that a lot of you are going to have a lot of questions. I think the best way to are you supposed to be taking notes? I would, yeah, I would at least highly consider that. A lot of this is important. I wouldn't say necessarily it's all entirely new, but it is very important and it's going to help you a lot when we talk about our assignment today, part 2. I will leave this up so that way you can keep taking some notes and you can look at it for when we do the next assignment today. But this is all very important stuff. So yeah. Okay. So I'm well aware that you're going to have a lot of questions. I will answer them when once you start the assignment. So the assignment today is on campus. It's called Codenames Velocity Part 2. I'm going to link it right now. So in this particular assignment, you have one graph that you're going to analyze. You're going to try to figure out what some distances are, some displacements are, some velocities are over some specific intervals as well. And so you're going to be doing something very similar to this, but you're going to be applying it to one specific graph, and you're going to try to use your knowledge to try to figure it out. You can do this in a group, or you can do it individually. I believe there is one. If you ask to work individually, I put you in a room with other people who also want to work individually. It's just easier for me to answer everyone's questions at once instead of having like 4 different breakout rooms with one person each. But if you wanted to work alone, you're welcome to do so. And I put you in a room with other people who want to work alone, so it shouldn't be an issue. Other than that, most of the rooms are the same. I made some small tweaks here or there to try to accommodate what people wanted to work with or accommodate any changes. So what I'm going to do now is I'm going to send you off in your breakout rooms. I'm going to let you get started with Codenames Velocity Part 2. Please let me know if you have questions. I guarantee you're going to have questions for me. If I feel like you don't have any questions for me, I will make you ask me a question for it. So I'm going to let you get started. I'm going to open your breakout rooms so you can start working on it. And then we will see where we are at the end of class. So yeah. Okay, we are out of time here, so I will end up here. I was able to answer questions for a few groups. I wasn't able to answer questions for everybody. So if you have a question, I'm sorry. I'll just let me know and I'll try to answer them. Homework is this will be due by next Thursday, Friday. So you don't need to finish this over the weekend. I would recommend at least working on it a little bit, knocking out maybe some of the easier questions, or at least figuring out which questions you have questions about. So that way on Tuesday, you can come and ask me questions, or you can come during office hours and ask me questions. So I would recommend you at least take a look at it over the weekend. Don't leave it all for next Tuesday. Other than that, we will pick this up on next Tuesday. We'll try to, and then we'll have everything finished by next Thursday, Friday. I have office hours again today, 2:40 to 3:40 if you want to come by. Other than that, I will see you all next Tuesday. Have a very nice weekend. And yeah, bye-bye.
Thank you.
Thank you.
Bye.
Thank you.
Thank you.
Thank you.
Nacho
you.
fries are back where?
At Taco Bell, duh.
Oh, okay. Sorry, I haven't been to Taco Bell in a while, so I apologize for that.
I had a question about the surveys because I did the one that's mandatory for participation, like the one for Wednesday. I don't know when you want us to do the weekly participation.
We'll do that. We'll do that next week, for next Wednesday's asynchronous stuff.
Okay, and is that like referring to last semester or because we just started, so we can't really say
It'll be
like,
referring to this semester.
oh, because of like what we're learning right now and what
Yeah,
we're doing.
yeah.
Okay.
Yeah.
Bye, Mr. Who.
Bye.